Hi guys, I hope you're good since the last video. We have 7 topics left. Congratulations for the ones who have made it to this video. You don't know yet, but statistically, you are special. Only 4 to 5% of people watch videos to the end. And this is lowering the potential that you arrive to this stage because it is for every single video like that. It could be the same 4 and 5% warriors, which made it this far. You're almost there. This is a message to encourage you. The number 7. After you finish this video, the number 6. 6 videos left after this one with very interesting topics, and you can treat yourself and go outside a bit. Then come back home to build your secret empire. Have a break, have a rest. In this video, I'm going to focus on REST's generic types. The first part will be explaining it and comparing with some of the types that we've seen in the previous videos, just for you to understand why it is interesting to use generics. In the second part, we will show how powerful it is. There will be 2 different examples that we are going to analyze and experience. Open your terminal and follow along. We'll have a fridge break for sure, but you can pause the video as always and come back to clean up those compiling errors. Please like and subscribe. Thank you again for your support. Okay, let's get started. Generic types. So the first question coming to my mind, I know enums, I know structs. Why would I need generic types? So why use generics instead of enums, structs, and other features? So we're gonna just compare those and say what they are used for. Enums and structs are fixed in terms of the type they can contain. They define specific data structures. The boxes that we've seen allow for heap allocation and dynamic polymorphism, but they do not provide the flexibility to write a single function or type that works with many different types. Generics solve a common problem. They allow you to write abstract and reusable code that works with multiple data types without specifying those types upfront. So just to resume here, with generics you can use any type, and that generic function can be used by all of the other, you can implement it, you can use it with all the other threads that you're going to create. They can help you create data structures or algorithms that are agnostic of the specific type being used. So here, agnostic of the specific type. So any type can be used, as long as those types meet the constraints specified. Enables code reuse, ensures type safety at compile time, not at runtime, like we've seen with box. Type or box enum, so having an enum as the type of the box. So for example, box checks at runtime, which can increase chances of getting errors at runtime. While generics, all those types, they are checked at compile time, which is better. Let's see different examples, just going through the example pretty quickly, and after we're going to compare. Print function using debug. So print debug, we put a T, and here the T is of type debug. So standard library FMT debug. And after, just gonna here, and after here, the T goes here, has a value. So that's the same type of debug. And after here, we're gonna use the colon question mark to be able to print it. So this is an example of the T in print debug is a generic type. So this is a generic type. The constraint T, standard library debug. So that's the constraint. It's a type debug. Means that the type T must implement the debug thread. So whatever we use here has to be implementing the debug thread. Otherwise, it's not going to work. So this is the constraint. This is the condition. So allows print debug to accept any type that implement debug. Okay. Here we're going to see another example with clone. Clone a value using the clone trait. So those traits, debug, clone, they're available. You don't need to import any packages. You don't need to install any packages in the TOML file. You just need to import those, like here, std-fmt debug. So for clone here, just to go back to the example, we have the generic type. The type constraint is clone. So the condition, this type has to be clone. And here, the value of the type, the return, the same type. Okay? So this can be a string, can be a U64, can be a boolean, can be whatever type we want to pass in. There is this constraint. It has to implement this type. And after here, we do the value and we clone it. The T must implement the clone thread, which means it can be duplicated, allows the function to work with any type that supports cloning. And after here, we're just going to see a third example, compare two values using partial order and display. So here we create a function with this type, partial order, but this type has also to implement display. So using here the plus. So here there is two constraints to this type. It has to implement both to be able to pass through this function. After here there is a number of different variables. They all have this type with the same constraint. And after here we're going to compare those two. For example, for this function, we're using partial order to be able to compare those. And after we're going to print what is less than and what is greater than. The type T must implement both partial order for comparison and display for formatting with curly braces, compares and displays values of any type that meets these three requirements. Okay, so this is the introduction to generics. You can see here how it is formatted. We are before the parenthesis, put here the type and the constraint, and after we use the same type for the parameters, which are actually using this type. Now let's do a comparative table, because we've seen structs, we've seen enums. So I had this question to my mind. What are the differences? So I'm going to just fast forward this. Those are the different features. We're going to see some more after that. Here we got the generics, the structs, just the normal struct and the normal enums. For the definition, so here you already know the definition. The type flexibility now. The generics are highly flexible, can work with different types with the same code. So I would say it's reusable. And here the struct normal types are fixed, no flexibility once defined, modifying the struct without modifying the struct. So here just tell to yourself that when you create a struct, you got those fields and it's limited to those fields anyway. Enum, each variant has a specific predetermined type of value. Okay, so here it's a little bit better than a struct, but it's not better than generics, because here you have to define the type anyway. Example syntax. So here we just show the different syntax. This is a struct. We use for the struct generic type t, and here we have the same t. And here we can add a constraint if you want. So this is how you're going to define it, making it more flexible. And here the struct, you see how it is defined. There are the fields, and this is a fixed type, I32, we can't change it. Enum does the same. It's very explicative, it's nice. We know it's a circle, it's a rectangle. Very nice utility, but the types are fixed to F64 in this example. Use cases. So when do you use generics? Use generics when you need to implement behavior that works with many types. The struct, we would be using the struct when we have a known structure with a fixed set of fields. So this is our Python class. So when you define, for example, I don't know, a bicycle, and you have the wheels, and you have fields that are defined and they're not going to change. Enum, normal. When you need a type that can take multiple forms of variants, like an enumeration. So enums, what is good with that is that you can have different types defined in the enum, and you can reuse it somewhere else. That's what is interesting. So it gives us a lot of flexibility. Let's see the end of the table, which is a code reusability. So this we've talked about it already. Generics, highly reusable. So the highly reusable can write generic code that works with any type that implements the specified trait. For the struct, it's less reusable. Changes to a field required modifying the struct. Same here for the enum, less reusable. Adding a new variant require modifying the enum. Example use cases. So here same generics, generic data structure like a vector with a generic type. So you know when you define a vector, normally you need to put here one type, like say it's a vector of strings, it's a vector of U64, and so on. But here you just put the generic type, and at this time this vector becomes more flexible. So we can use this one for any type. Collections, sorting functions. So we use generics for those traits, collections, and the functions. For the struct, fixed field like geometric points, complex numbers, fixed data models, or example of the bicycle. So when you want to define an object, you can use a struct also. Enum, type that can have multiple different forms like option, result, or parsing JSON where data structure can vary. So enum is very, very flexible, but doesn't have this type functionality, this openly typed functionality. Example of instantiation. So here, let point. I just put the point. So here for the instantiation is the same for the generics, but I should have used maybe vector here as an example. It's all right. You already seen for the structs on the enums how to instantiate those. All right, so we're done with this explanation part. We're gonna jump into the terminal, but before that, let's have a little fridge break. Okay, so that's what we did last time. Now let's create a new file. We're gonna call it generic manga, or maybe manga kisa, rs. Let's stay in the same examples. So I'm gonna start the example 1 straight away. We'll be commenting as usual, just to explain what we're doing and why we're doing that. So the example here is gonna use what we know, Struct and Enum, and we're gonna evolve slowly and understand why using those generic types will help us and make it easier. So example 1, struct with enum fields to be able to have several types. So we're going to create a public enum. So I'll put here public, but I'm not sure yet if I'm going to use it in the main.rs. So MongoKisa type, that's the name. It's got an issue of type string. Feature request of type string. An improvement. And here we're going to make it a little bit more complex in structure. We're just going to say there is a details field, which is a string also. And here we're going to maybe use a number for the priority. A U8, just to prioritize those issues. So what we're going to do in terms of scenario, we'll be receiving the tickets from customers or from one department in the company. So this enum will be listing those issues, giving us the chance to define description of the issue and the request. Maybe they request a feature. It can be also the marketing department requiring a feature after having done a survey or studies. So here, improvement, suggestion with details on the priority of that improvement suggestion. Okay, so that's the scenario. So we'll be creating tickets, and those tickets are going to be using our structures. We're going to implement the debug mode straight away, allow dead code, so that we don't get any warning in the terminal for not using the enum. Because they will be part of the example in which we will be using. Some examples we won't be using the enum. Same for the struct. So here I'm going to create a struct. I'll make it public for the moment, as I don't know if I'm going to reuse it. Let's leave it public for the moment. For the fields, I'm going to leave the fields private. So the struct is a ticket struct, has an ID, an I32, has a name. So here it's a string. And so ID, name, and maybe MongoKisa type. And here we're going to use the enum, MongoKisa type. Okay, the enum that we've created here. We're going to use it here to have a nice struct. So this is the advanced way of using it. We've seen it before. We are at this level now. We can use enums in struct. Let's just go for that. So we can comment maybe using the Enum here allows us to handle different scenarios. Okay. It is still limited to the Enum fields. Okay. So that's why as my first question in the explanation part. Why would we need generic types when we can actually use enums in structs and extend those structs and have more flexibility to it? That helps to prevent having huge structs. Because in fact, a struct you can define everything in a struct, but using this technique helps to be able to reuse the enum somewhere else, and here also to have just all combined in one field. And don't forget that when you instantiate the struct, you need to define all those fields. So you need to provide a value for those fields. Okay. So using it like that, Mangakisa type, for example, we can just use one field of the enum. We don't need to use them all. Here we go. So the struct has been created. Now it's time to maybe create a public function. This one for sure, I'm going to be using it in the main.rs, because that's the one which is going to be launching all the logic of our example. So here, public function, manage any manga kisa type. I just call it like that. I could have called it manage any issue happening in manga kisa. So here, let bug ticket. We're going to create a variable here. It's a ticket. It's a bug. So here we're using ticket, which is the struct, and we're going to instantiate that struct by defining those fields. We got the ID, we said it's number 1. We got name, we're going to put the name after. So it will be just the name, anything that we can put in. But it's a string. Mangakisa type. So here we need to instantiate the enum. And here we're just going to use one field of the enum. Mangakisa issue, as it is a bug. So we're just going to use the issue. This is the type that we're using. String from. And here same will be defining the string in. Let's put those. Okay, this is done. And now I'm going to do the same for that. And we're going to write a little sentence just for the name. Help tourists find their way in manga kisa. Labir. So it's a huge manga kisa. Has several floors, and tourists are always losing their way, and they don't know where is their reserved seat, even if there are numbers. Have interactive map, so this is for the issue, where for people to know where they are. So maybe this one I could have used it not for a bug, for an improvement. Let me just use the little trick here to copy it. I'm going to copy it and I'm going to transform it to an improvement or suggestion. So we got feature request or improvement. Let's call this feature ticket ID 2. And here, so I'm going to modify the one that we did before. As it is a bug, I'm going to get rid of this. And this one that we have defined, those sentences are more like a feature request. And here is of type, so the Enum using the feature request field. Okay, here also I can get rid of this. And here for the bug, the issue. So let's give it a name. Maybe say just the name of the manga kisa, Shibuya Kokoro Manga Kisa, level 7. Okay, so that's the Kokoro Manga Kisa. Sounds less anime playing on screen. Can't hear anything. Okay, so animes are playing on screen, but there's no sound. So that's the issue. So we got 2 tickets. Let's just paste here and modify this to make our third ticket, which has an ID of 3. We're going to change the sentence. We can also change the type of ticket that we're doing. So let's get rid of those sentences. And now here, instead of issue, I'll call it improvement. That's what, yes, improvement. So what are we going to improve? Screen display of anime. So we're going to optimize image for better rendering and immersion into the anime art. All right. So this is an improvement. Okay, we're using this field here, improvement, but we need detail and priority. Can't just put a string like that because it has its own structure. We're going to follow the same structure here. So we're yes, this one. So here this is details. Okay. And after here, the priority, let's say is of priority 2. Okay. Now that we got those variables, we're going to use println and get those tickets printed. Okay, using the debug. So bug ticket. After that, we had the second one, which is feature ticket. Yes. Feature ticket. So this one is not bug ticket, it's improvement ticket. So that's when you copy and paste. I could cap this error now, but there might be some other ones. We will see. We're gonna print. It's part of the exercise to be able to spot those errors in the terminal and come back to the code to modify those on the fly. Improvements, ticket, debug, improvement, ticket. No need semicolon here. I think we're good. Okay. So, we got the enum, the struct, the function, the three variables that are being instantiated in this ticket struct. Okay, manga kisa. I'm just going to copy the function for the main.rs. Let's go to main.rs. We're going to call the function from here. So generic manga kisa type was the name manga kisa. I didn't put type manga kisa. That was the name of the module. And after we're just going to use the double colon and use the function, instantiate it, and now we got it. Let's see what the terminal is going to say about that. Here we just call the function. Okay. So I'm not going to import the enums or the structs. Oh, I thought it's going to work straight, but no. So let's analyze what's going on here. Let's start from the top. So we can see here 32. The ID type in the struct is I32. So I omitted the I. So that's normal. It's going to create some errors. It says while passing the struct, I spotted that error. Also here, manga kisa type, improvement, details, and priority. So here I'm missing the curly braces. And you see here in green, it's showing me, the compiler is very nice, huh? It's showing me here where I should put those curly braces. So yes, I used the parenthesis, but it's curly braces, and here doesn't implement debug display. So we need here to use the debug mode for one of the print, which is feature ticket. So let's go down here. We put an I for I32. The second one was here. We need curly braces, improvement. Okay, not parenthesis. We put a space, open curly braces. We got the details. We got the priority, and we close the curly braces here. Not parenthesis. And after we got the print here, fixing it using a colon question mark, because debug implement display. So we can display this. What else? Okay, so here managa kisa type instead of manga kisa. So let's find this field. It is in the struct here. So manga kisa type. That's a typo. Now we should be good. So I haven't spotted this one in the first error display, but it's gonna come anyway. And now we're running it, and we got our tickets being printed. Okay, so we got our tickets with those different fields. They have advanced structure, different types also. That's one way to do it. And after, I'm going to create maybe a parallel example to the example one. So here we have seen we use the Enum, the Struct, but in your code you might be wanting to use that because you want to check on those also. So I'm thinking of using maybe a match or iflet for that. So we might need to go and create a new function. So let's go down the page and implement that function. I'm just gonna close this. Not yet. Let's just say example one first. Just for me to have all those examples, so I know which one is which one. Here I put the semicolon, we never know, and I can close it. Okay, so now let's call this one example one piece. Okay, and what we want to do here with pattern matching. So we're going to use pattern matching. So before that, I'm going to create the function. And after, we will be using the function inside the other one after having created a variable. So I don't need it to be public. Let's call it handle tickets. Let's take a ticket in. The type of the ticket is an ampersand ticket struct. So we're just going to take a copy of it. Not a copy, a reference. We're going to be referencing the ticket. We're going to match on this reference. On the field manga kisa type, you know, the struct has this field which is taking this enum, not manga, which is of type manga kisa type. And here we're going to use the issue, for example. We're going to use them all actually. So that's how I'm going to do it. I'm going to say here manga kisa type issue. If it is an issue, I wrote description, but that's just a placeholder to be able to reuse it in the print. And here let's put our string literal and the issue. And here we put, it's just a string. Don't need debug for that. Put the description. I don't know. Do we need debug? I will see. So print ln. I'm just going to copy this. We'll be repeating that twice. So 3 times in total. So here. So manga kisa type. We're going to cover the fields of the enum. Feature request, handling feature request, and here we're going to go for improvement. Okay, so improvement. It's a bit tricky for improvement. We can't use the parentheses and get the same error that we got before. Because here we have details. and priority. So let's put this in parentheses. Let's put this between the curly braces instead of parentheses. And let's unwrap. Here is the same. We will use also, we put everything between curly braces. Just checking on the, how I'm gonna format this. Maybe here. This one, I keep it like that. Handling, improvements. I'm going to print both. So here with priority. Okay. And we're going to use detail and priority instead of description. So details and comma priority. Okay. This is well formatted. Improvement. Okay, between curly braces, details and priority. That's what we want to pattern match on it. See here, improvement. We got those curly braces and it's in details and string, which is a string and priority on your right. Manga Kisa type here will be the field of the struct, which is the Enum type. That's why we can check on those Enum fields. Okay, so the function I believe is done. Let me close this comment. So we have the function handle ticket, takes the reference of a ticket. Okay, so take the reference of the ticket and place with it here to check Manga Kisa type. So we need to use reference again because we're going into the field Manga Kisa type. So we take in the reference of Manga Kisa type field. Okay, so that's why you need to use ampersand again when you're doing the match. Okay, that's why here we need to use ampersand ticket Manga Kisa type. So now we can go back to our function. And here what we want to do, we want to create a variable and which is going to instantiate that struct. And we're going to call the function on it using its reference. Let ticket. And here the ticket using the struct. Let's instantiate the struct. We're going to create those values for each field. ID is 1. The name is a string. We're going to format the string. Add new login feature. Manga Kisa type will be of type of the Enum. Manga Kisa type. And we're going to use feature. So here you can see the answer because we're passing in feature requests. So when we're going to do the pattern matching, that's what we want to see printed. And after here, feature requests, string from, users requested a new login feature. Let's go with this kind of example. Let's do a pattern matching. Okay, we got the ticket variable. We got the manga kisa type here we've created, and we're matching on that reference of manga kisa type. And here we need to call the function on it. So handle ticket, and we put in the ticket &1, the reference of it, as defined in the function. Did I get it copied? Let's call it special ticket, so that you see that the parameter passed is a name different from the one used in the function. We never know if you're confused about that, seeing it called ticket. So here we just pass any variable that you define with any name, but you just pass the reference of it. Okay, so we got here an error, a comma, expected one off. So maybe we don't need the comma here. Let's go back to our... Okay, let's go and check where is the issue. Here, let's get rid of this. Okay, should be fine now. Okay, and we see handling feature request. User requested a new logging feature. So this works fine. We use the struct. We used Enum. We combine those to make it more sophisticated, more advanced, have more flexibility in the types, especially for the manga kisa field here, manga kisa type field, which is using the Enum. Now we are going to enter into the subject of the video by seeing the example of generic types. I did this example first so that you can see the difference between both in terms of implementation and how it can make your life easy. Okay, let's comment out what we're not going to use anymore. So in terms of struct on Enum, we don't need this struct anymore, not in this form. So I'm going to create another one with the same fields, but using generic types. Okay. Let's see how it's going to look like. So we tackle here example 2, which is now the same, but using generic. Okay, I'm just going to copy the decorators. Okay, here we can, I put it public for the struct, but we don't need to put it public, because as I told you, I'm not using it in the main.rs. So that you see different ways. Public for everything, all the fields or public for only the struct, or just keep it private. So should be U32, not I32. Like in the previous example. So I won't forget here the U. When in the first example I got this error because I forgot the I, but it shouldn't be a I32, it should be a U32, it should be a positive integer only, because it's an ID. Let's do it right. The name is still a string, and the data here we use the T, generic field, and you see the struct ticket. At ticket we use T also. So what is cool here is that we don't need the enum anymore. So the enum is just staying on this page. There is already the decorator saying allow dead code, so we won't get any warning because of that. So just seeing this definition of this new struct, you can tell that it's going to give us more possibilities. I'm going to comment this out. And here, example 2, that's the one which is going to be called by the main.rs. Let's create our variable from now on straight away. We're going to call it bug ticket. So we're going to do those tickets again. ID1, the name, we create a string, and the data, which is of type T now. So let's, for the name, put Shibuya, Kokoro, Manga, Kisa, level 7. Let's use the same sentence. The data was a soundless anime playing on screen. Can't hear anything. ToString. Do I need ToString? Yes, for the data. So here we're defining a string. So data is a string. So we got our bug ticket. We used generic types. What is good is that we have different fields. Some fields we have defined the types. The strictly they have to be those types. And we just left one field to be able to use this generic type. And now what we're doing, we're creating those variables. And at each variable, when we write this data, we're going to try to use different types to see how flexible it can be. Here we can maybe use a vector. Let's use the macro. We're going to put here a sentence inside the string. Just Get rid of this and that. Let's put everything in the middle. Let's use the same. Should I use help tourists find their way in Mangakisa Labir. Here we go. In the vector, we can put a user request. This request of a feature can come from the sales department. Let's say just the last one can come from the marketing department. To vect. Data is vect and %string. After here, we're going to create the last one, which is going to be an improvement ticket. Name, we're going to put here, so the ID is 3. Let's just use maybe the same screen display of anime. And here, the data. Let's use here because we had details, we had in the Enum priority, so I'm going to use a tuple maybe. Let's do this. Let's do a tuple here. So Rust is going to infer the type by seeing the parentheses. On the inside, we can use string for the first field. So here it's very flexible. You see, we add the data when we arrive to it. We just define it the way we want it. We give it the structure that we want also. And just write the same sentence that we used in the first example. Optimize image for better rendering and immersion. To display the anime art. Priority, it's 2. And we're just going to print those as we did before in the first example. We're going to make it simple. I'm not going to be writing too much here. Just println. We want the output of the variable directly. Try to not forget any colon, question mark. That's good. And the last one, improvement ticket. We don't need colon here. Okay. So everything is good, looks good. It always looks good before going to the compiler. We got our ID for the bug. We got the second one. This one is a vector. This one is a string, while the other one here is a tuple. Okay. Let me close this comment. Do not get any error for that. If we get any error, we are going just to come back and fix it. Okay. So here, allow dead code. So the enum, we're not using it. Okay, Mangaki is a type, so we won't get any warning because of that. We don't use the enum. In this example, not in this example, for example, that's what I'm in this example. So this will allow clean terminal print without warning. So this we got it commented. So that's good. Just gonna write some comments just to explain a little bit. Okay. So here there's comments to do in this struct. What should I say? When using generics, we do not need the enum anymore. Okay, so instead we're using the T as a type placeholder. The struct also becomes super powerful. You see how the struct now gained in power at this field. So I called it data. As now it is type agnostic, as we've seen in the explanation part of the video. So now this field is type agnostic, while the other field is strict, strictly U32 and strictly string. You can do that like that, because in the examples that I showed you in the explanation part, you were just seeing T everywhere, but you can also just decide that only one field should be a generic type. So it's better for our code base. If the marketing team, let's just have some scenarios in our head. For example, if they decide to implement some more tickets. So here we gain in scalability and reduce complexity. So as a Python coder, when I see something like that, I want to just use generic types everywhere. Okay, so here we use the T. We got the structure now, how to define it, just for this T field data. It is type agnostic. Alright, you got it now. I'll repeat a lot, but that's the best way. We got the bug ticket with a string, the data. Here the data is a vector, and the improvement, the data will be a tuple. After we print those, we might be ready now to go to the terminal. Okay. Let's see, what's the error? So missing data. Here we're having green tickets. Tells us to use the T, but the error, that's why you need to start from the top. So the error comes from the comment hasn't been closed, as you can see here. So the compiler is trying to infer. Also here we missed a semicolon when we define the variable. I believe those are the two errors. All of the rest is just the compiler trying to guess. Because, okay, let's go and fix those two. Where is the comment? So first, we don't need this function here, because we're not using it at all. Let's close this. That's for one error. And here, there's the comment. And we had the semicolon somewhere. This one. Let improvement ticket. I'll try to keep all in one page, so I can forget sometimes. Cargo run, and here we go. We got a ticket, the first one with the data type string, second one with our vector, and the third one with the data, which is a tuple. That's nice. So now you've seen generic types. But what's happened if we do we need actually to match on the types? As you've seen the first example, we needed to use a function. That function using a matching pattern in order to check on those types. So depending on which type is the variable, it's going to be returning a different print. So here we're going to be exploring that in the second part of the example 2. Let's go in. So I'm just going to comment out the example 2. Let's comment it out until here. Very good. And now we are ready to start example 2 still, but this, the second part of the example 2, that's the last one that we're going to see. It's an interesting one. So here what is interesting is that no more pattern matching. So we don't need any more to do those pattern matchings on the generic types. So what we can do, we can create a variable here. Let improvement tickets. Okay, we have the ID 3. We'll just define those fields one by one. Let's write a string here, a new string, Mori Tower Rigoletto Italian restaurant. That's let's say the name of the improvement. So at this restaurant, we have a tuple at data. You know now that at data we can put any type, but we're gonna just use tuple. It's very easy to format and write straight away. And we're gonna write our string. And the string here is gonna be Just let me put it like that. So we can have all in one page. I'm making the format like that because I might make some shorts. That's why it's centered to the screen and everything. So I have a VIP seat for Creditizens on Saturday nights. Okay. Have always a VIP table available for Creditizens. Priority is 1. This is very important. So very high priority is 1. Just for you to know. Same for the Mangakisa screen display. 2 is very important. That's why we go there. Work. So I'm just going to put here works for any ticket. Now, as we have ticket T, it's a generic type. That's what is cool with that. Now I'm going to go down here, call it just example 2, and create a function. Okay, 2 bis. And this function, instead of using pattern matching, so we can use ticket directly. That's what is cool. Let's call it, okay, we do not need pattern matching. I just precise it. I'm just going to comment a bit. Anymore. Call it process ticket. Generic type, T. Of type, use debug, so we can print. Okay, so that's the constraint that we use. That's the condition. Okay, and the debug is implemented because we use the decorator, deriv debug, as you can see. Not in the Enum, but here we can just import it like that. I want to use just the debug instead of using everything. But in the struct, I put the decorator deriv debug in the struct. So it should be fine. And here has a parameter of the function. We're going to pass in, let's just call it ticket. It's same here as the previous function that we did with the pattern matching, is a reference of the ticket using that generic type, which has to implement the debug constraint, the debug condition. Okay, so we pass in ticket is going to be an ampersand ticket to pass in. Okay, and now we just maybe just print. Let's do the formatting. So, what are we gonna say in our print? Put it here. String literal, and we're gonna do a formatting processing ticket ID. And here we're just gonna have the ID and use the name. And here we're just gonna put the name. And now let's call ticket ID, ticket underscore, dot ID, and ticket dot name. It's just printed. Dot, okay. I'm going to do another print, so I'm going to use here a semicolon. And let's do the second print from here. Println ticket data, and for data we're going to use colon question mark. Okay, so we can print it. That's why we use the debug constraint, which has implemented the display. That's why we can use colon question mark. And the field data can be any data, any kind of type. So that's why we use that. Each ticket has its own data type. So that's why we don't need anymore those pattern matching on the ticket data. We cannot mistakenly use wrong types for data. So that's the field we were checking, especially. That's the one pushing us to use those generic types. Once the ticket is created, it's reducing errors. Okay, we cannot mistakenly use wrong types for data once the ticket is created, because it's just going to follow the type that has been defined. Process tickets. Let's copy the function. We need to call it. We have another part of code, not to forget, and we're going to instantiate it from here on that variable, which was improvement ticket that we have just defined. Okay, so it works for any ticket now, as we have ticket with the generic type. So the data field can just be whatever. Implementing debug. So thanks to that, we'll be able to print it. That's our constraint. We want that type to implement debug. I'm just going to write it this way. Works with any types, any ticket type, implementing debug. Okay, with T, implementing debug. Process ticket. We need ampersand. I put it first so I don't forget it. Improvement ticket. We close those comments. I believe there's no other comments. Improvement tickets. We don't need the semicolon here. We close this. This is the last statement of the function. Cargo build run. Yes, as you can see, processing ticket ID 3, name Moritoro Rigoletto Italian Restaurant, and the ticket have a VIP table always available for Creditizens on Saturday nights. So if you arrive to the end of this video, for sure you are part of the VIPs. We have seen how generic can be used to have a function that can be implemented by multiple other objects, allowing the same functionality to be shared across the code business logic. We have seen that types are inferred at compile time, which is safer for application reliability than the boxes that we've used in the previous video, because those ones, they're doing it during the runtime, those types checking, which also can be affecting the performance. Okay, and after that, it can also create errors. So because it's at runtime, it's better to catch errors at compile time. When the app is running, it can be a user-facing app. For example, it's an issue. So the advice here for structs, as seen in the hands-on examples, use enums to simplify and make your struct more flexible if you know all types ahead of time, especially if those are fixed and can't evolve. On the other hand, use generics. When you want, you use it in your struct when you want to have it to take different types and be really flexible, allowing types to evolve and change. Right? We stop here. Hope that you liked this video. Thanks for the support again. Please like and subscribe, and see you next time for another have a break, have a rest session.